Okay, 503. Let's start. Eduardo Idarski speaking here. I guess welcome to the Voltimum webinar to all of you. We'll wait maybe a few more seconds. Thank you for attending this webinar. By the way, at the end of the webinar will be a very quick survey, so we will ask you to answer a few questions. I'll remind you anyway at the end of the presentation later on. Okay, what we are going to do is just to go through a brief introduction of USB chargers, and I think I will probably I can see a couple of questions now. I will be able to answer some of the questions. Those that they are not able to answer due to time or just the technicality, we will do them in due course. So thank you anyway for all your questions. Okay, let's move on. What we are going to do is to talk about a very brief history of USBs. We are going to talk about what are the main trends driving the use of USB chargers. What are the common issues with power chargers, and what are the environmental issues with power chargers as well? What are the elements or the key elements to look for a USB charger, and what are the opportunities for USB chargers in the construction industry? I presume that everybody's hearing me quite well. We tested the audio before. Just in case if there is any problems, please use the chat channel, and we will try to address the problem. Brief history. Well, the Universal Serial Bus, or USB as we commonly know it, is an industry standard that was originally designed by a group of 7 companies around the mid-90s. Now it's evolved from 7 companies to many more involved in the development and progression of the standard. One of the main objectives was to reduce the clutter and the time to plug multiple devices to a computer. Ajay Bhatt of Intel was one of the main architects involved in the design of USB standard, and is often attributed as the rock star. Probably you've seen one of the some time ago a television ad of Intel where they call him like the rock star, but it basically was one of the fathers of the USB standard. USB evolved from a socket capable of supplying limited power and serial data interface to a socket used as default provider of power to phone, tablets, readers and many other mobile devices. What are the main trends driving the use of USB chargers? Well, one of the recent studies performed by Cisco and other experts predict that Australia will use in excess of 3 mobile devices per capita by the end of this decade. USB standard is constantly evolving, and the battery charging specifications, revision 1.2 was adopted in 2010, allows up to 5 amp charging current in the USB 2 type socket, which is pretty much the picture that we've got at the beginning of this presentation of the rectangular, the very common, the most common one that we normally use. USB sockets are widely accepted as the power source and have become the de facto power module for today mobile devices. Even further, some mobile phone manufacturers are already shipping their products without a power adapter. So these are the main drivers to put, I guess, everybody in context. Now, for technical questions, we will have some time later on as well. What are the common issues with power chargers? Well, typical issues are simply inconvenience. The difficulty today is the need to carry around multiple chargers, swapping and changing plugging units, and the risk of losing them and not having sometimes enough power points where to plug them into. The constant need of power. How many times we run out of power when we need it the most? We need it at home, we need it in the office, at the airports, and in many other places. inadequate charging. There is a huge variance between available USB chargers out there in the market, and using inadequate chargers may have a negative impact on the longevity of the battery and its performance. What are the environmental issues? Well, that's also very important. Incompatibility of chargers is a major environmental problem. A user who wants to change the mobile phone must usually acquire a new charger and dispose the current one, even if it is in perfect conditions. Even at home, I've got in here probably 3 or 4, even more, plug-in units that they're all in perfect conditions, but simply they are just incompatible with the latest mobile phones. This situation is unnecessarily generates important amount of electronic waste. Plug-in units with poor standby energy consumption can also generate significant amount of energy waste. Standby power is a very hot topic as well, and we all need to reduce the standby power as much as we can. Now, what are the key elements to look for a USB charger? Well, the basic things such as the maximum charging capacity. We need to have the ability to charge, or the ability for the charger to provide maximum current when you need it most. The standard today is 2.1 amp per socket, which allows you to charge an iPad at full charge, at full rate. Simplicity, the ability to integrate USB chargers in a wall switch or power outlets. We need power everywhere. We need in the kitchen, we need USB, we need charger in the kitchen, we need in the bedroom, sometimes in the living room, in the office. So we need to have the flexibility to be available in different configurations and different form factors. Flexibility, ability to install the charge in a place where you normally rest your mobile device, bedside table, kitchen, as I just said before. Another key element are the overload protection, to protect the charger circuit in case of a faulty cable that could cause a short circuit on the 5-volt side. Well, this is pretty obvious. Even again, I take the example from home, and how many cables do we go over in a matter of months is just unbelievable. Simply the kids pulling the cables and they get broken, they get short-circuited. So overload protection is very important. Low standby power consumption, as I said before. I understand there is a ham noise. I'm not too sure if I would be able to do too much about that. Hopefully you can all hear me well. I don't have any feedback, so I cannot tell you exactly what the humming noise is, but please let me know if it is disrupting the presentation. Hopefully that solves the problem. I'll just turn the lights off in here. Compliance. Sorry, I was talking about the low standby power consumption required to minimize energy consumption while the charger is not in use. The benchmark these days is to have less than 0.1 watt, 0.15 watt of power in or standby power. Compliance with the standards, that goes without saying. Standards have been updated to cover battery charging mechanisms and power sources, so obviously chargers must comply or should comply with the standards. What are the key elements to look for on a USB charger? Again, we are looking for energy efficiency, optimal circuitry for maximum energy efficiency, performance in Mark 5. That relates to the I can see a question I will try to answer in a couple of seconds. Sorry, I was talking about the energy efficiency optimized circuit. That's also important to ensure that the energy that we draw from the mains gets transformed to the maximum possible into energy going into the mobile phone or the tablet. So the minimum energy performance standard MIPS specifies all this and different performance levels, and performance at Mark 5 or level 5 it is the maximum, and I think we should aim at that level. Variable charging rate circuits, smart charging circuits that adjust charging current to optimize speed and to protect the life of the battery will often happen that I've seen chargers out there, they don't regulate the current properly, and that could potentially or literally cook the battery if the current is not variable. Now, what are the opportunities for USB chargers in the construction industry? Well, we divided the opportunities in 3 different areas. There is a question from Tim. I'll try to attempt to reply to him a bit later on. Living areas, we define them as a long time stay. Then we've got starting and working areas in a medium time stay, and waiting room areas in a short time stay. Now, if we talk about the living areas or the long time stay, we define them as houses where the benchmark is to have at least 2 dual sockets in a kitchen and at least 1 dual socket in each bedroom. In the student room, in universities for instance, is again 1 dual socket in the kitchen and 1 dual socket in each bedroom. In hotel rooms, at least 1 dual socket in the study or beside the bed, and hospitals is also becoming very popular to have 1 dual socket per bed. If we talk about the starting working areas, sort of a medium time stay, like offices and workstations, we need at least 1 dual socket per workstation. In libraries, 1 dual socket per study table, and in student rooms 1 dual socket per study table. And in short time stay, how often we find ourselves at the airport lounges and waiting rooms, etc., and or train station public rooms like councils for instance, or RTA, or etc. So in these sort of environments we would expect to have at least a charging station with multiple sockets are there, depending naturally on the number of on the size of the place and the number of the traffic, basically the amount of people that attend these sort of places. Now we, as Legrand, we offer a USB charging module that can be assembled in a single, double, Excel Live, Excel Linear, and RTO PowerPoint or multiple gang configuration. These are sort of traditional HPM Legrand different product lines. The Legrand Excel Live USB charging module has been designed to provide the maximum charging speed. We've got a dual socket, and each socket provides 2.1 amp of charging power, just to maximize the charging capacity, and with the although it's not written there, but we have a standby power of less than 1.5 watt when the socket is not used. And finally, just happened last week. I guess I feel obliged to mention that, but HPM Legrand, this particular USB socket was recipient of a Good Design Selection Award, which is awarded by the Australian Good Design Awards. This is very interesting for us. We work hard to achieve this, and anyway, hopefully we will be able to come up with new products in the future similar to these ones and other type as well. we've got some time now. As I said, it's a very brief presentation. It's very pretty much high level overview. I can see there are some questions out there that relate more to technical nature, and I will take them on board and I will reply to those directly. In the meantime, we've got a few more minutes, so we will take them as questions and answers. You're welcome. I welcome you to send to use the chat channel to send questions, and I will try to answer them as they arrive. In any case, in the meantime, I'll really thank you for your time. As I said earlier, at the end of this presentation will be a questionnaire that Voltimon would like you to fill in. So I'll let you do that at your leisure. Anyway, any questions? Please feel free to do that. There is a question here from one of the attendees that says, can the sockets be networked on LAN or WAN? These particular sockets are charger only. They don't have, if I understand the question, they don't have any networking capabilities. It's just simply charging modules. There is a question from Tim that relates to, I'm not sure if I understood the question here. It says, can you please explain how long iPads / Samsung tablets actually, it says us, so it's not clear the question. I would probably ask that person to either rephrase the question or just to type it again. Question, I can see it now. The question was how long iPad, Samsung tablets actually use 2.1 amp for charging. Well, it really depends. We try different charging, different tablets and different versions. Some iPads, depends which version it is, charge faster than others. From memory, it takes, we did compare actually with the original chargers, and it's exactly the same. It doesn't charge any faster. We provide the same charging capacity as the original Apple chargers. So obviously they do charge at variable rate charge, so they change the rating. The charging rate depends on different times, and that usually is managed by the device itself. Let me try to read another question in here. Do they use 2.1 amp? Let me read another question. Do they use 2.1 amp for the complete charge cycle, or just for a small portion of the charge cycle? No, it's only for a portion of the charge cycle. We regulate the current, depends on the demand of the battery. Otherwise, if we charge 2.1 constantly, obviously at a certain point we will cook the battery. I was saying earlier, the batteries they need, when they're fully charged, they just need a trickle charge with a small amount of charging current. There's another question here. Are they wired into the power circuit without additional circuit breaker protection, or do they require the on circuit? I think I've got a, oh, I can see, let me see if I can try to read. I've got limited space on the window. Are they wired into the without additional circuit breaker protection, or do they require their own circuit? No, they are directly wired into the power circuit. The USB charger is plugged into the socket. It's mechanically attached to the called the GPO, the general purpose outlet, and the 240 volt side is actually wired straight into the socket itself. So we use the circuit breaker of the GPO for the circuit breaker for the USB charger as well. There is another question in here. Will more and more appliances move to this protocol? Children toys, electric toothbrushes, etc. Well, we do see that happening more and more. I mean, that there are a lot of gadgets today, not necessarily mobile devices. I mean, we've seen fans and lights, and I can see in the future, even I'm aware already of screens, LCD screens, so to speak, or LED screens, monitor screens, etc., and lights, standing lamps, and desk lamps, all USB compatible, coming already with its USB socket, so they don't need any more the plug-in units traditionally that we used to plug into the 240 volt side. I have seen a USB charger on, there's another question in here, I have seen a USB charger on the Australian market that has NFC in it for interacting with the mobile device. Do you see how that could be beneficial? Well, it's just only, the only thing I can think of is it's a question of price. I mean, there is a big variety of, as I said earlier, big variety of charging mechanisms and big variety in prices as well. Sometimes I see prices and I pull my hair out thinking, well, obviously, and it's funny because I put the chargers in my hand and I can tell you which one, I try to measure the weight, and based on that I can tell you which one is a good charger, which one is not a good charger. I mean, obviously it's a very rough and non-scientific measurement, but simply some of the chargers are really bad out there. I'm not sure if I answered that question. If not, please just confirm. Any more questions? We've got a few more minutes still. There is a question here. It says how much heat is generated in the wall cavity. Well, the devices are the USB chargers that we have. They are pretty much over-spec'd in a sense that even if we charge two iPads simultaneously at 2.1 amp per socket, the heat dissipation is very, very minimal. So the device is capable to work in those conditions, even if there is no specific ventilation. Although the wall cavity on its own it's already is usually big. In some cases we've got insulation, foam insulation, but that does not affect the performance of the product. There is a good question in here. Does the charger fit in a wall box? This particular charger doesn't. The reason being is that we believe that we wanted to provide a full charge capacity. We want to provide 2.1 amp socket, and obviously we had to make a compromise between charging capacity and physical size. We went through this exercise and we decided to go through maximum charging capacity, and therefore we did have to compromise on the physical size. It's slightly bulky and doesn't fit perfectly on a wall box. Therefore that's why we provide sufficient cable length for the charger itself to drop into the wall cavity and sits in there. There is another question in here. Does Legrand have 240 volt power boards with USB sockets? Yes, there are a number of products in different channels, and I welcome you to visit the Legrand website, and you will find them all. Otherwise, you can send me a direct email anytime, and I'll make sure that we get you all the information that you need. We've got still a couple of more minutes to go. Okay, well, I think if there are no more questions, we will wrap it up. Again, thank you very much for your participation. I welcome any questions or any feedback that you've got. There is one question that I wasn't able to answer. It was a very technical question. I will reply later on. There is another question finally here that arrived. If we have to extend the 5 volt cable, what is the maximum distance? That is a very good question. We are already extending the cable, the 5 volt side, and we did some measurements, and we are able to confirm that the 5 volt cable can be expanded to up to 1.5 meter from my recollection. But obviously there is a small degradation in the charging capacity due to losses in the cable itself, but it's very, very minimal. Anyway, I will thank you all again for your attendance, and I will invite you to fill in the little questionnaire that Baltimore would like you to do. For any other questions, please feel free to call me. I'm at HBM Legrand, and you can always contact me directly, and I will be happy to answer any questions. Thank you again, and if there are no more questions, I will turn